Hey, Katie.
Hi, Ben.
Have you been watching the new series Picard?
No. Picard?
Picard, yeah,
Like,
it
is this a
is.
Star Trek something?
Yeah, like Captain Picard. It's well, anyway. I mean, this is a long and winding and strange intro that just brings me to mentioning Star Trek because I love it so much. But
Wasn't
what we're
that
actually
long.
going
Cut
to
yourself a break.
what we're actually going to talk about is the use of machine learning in enterprise scenarios.
Sounds good.
And there it is, the enterprise.
Haha.
You're listening to Linear Digressions.
I think there's probably about 4 people left with us after that intro. Okay, yeah, let's talk
No.
about machine learning in the enterprise. This is going to be a really good episode. I'm actually genuinely pretty excited about this. Okay, cool. So, machine learning in the enterprise. Couple of cool papers that I've been reading lately. As always, links on lineardigressions.com. And let's take them in order. So the first is...
Actually, just to define our terms, what do you mean when you say enterprise?
Yeah. So I roughly think of this as like big companies. And I know that that's not super well defined, but I think it's sort of like, imagine that you're a big grown up company that's subject to, like, I don't know, you've got a real legal team that enforces stuff at your company. You've got a risk management department. You've got accounting full of accountants who
Got
care. Your IT and security teams are fully staffed and care about managing your company. So it's not super strictly defined here, but it's sort of like big grown-up companies that need big grown-up software to run their big grown-up processes, and that there are certain requirements then that follow from that, if you are in the software space or really want to be interacting with these kinds of companies at all in most capacities, then you need to kind of have everything together. And so it's thinking about, all right, we've got these big established companies that have their processes and their rules and their procedures. What happens when you introduce machine learning into this mix?
Right. Yeah, because if you have a big, mature adult company that's been doing things a certain way for a really long time, it's probably more difficult to introduce new things, especially new, large, important things like machine learning that will definitely disrupt the way that things are currently done, and for the better if they're embraced.
Yeah, and nonetheless, though, exactly like you said, these companies are eager to plug machine learning into these processes and be using their data for machine learning models that are going to help them make decisions, potentially at a very large scale or in an automated way. So we have this but machine learning, let me step back here for a second. Machine learning is primarily has a set of software packages, internal practices, kind of infrastructure built around it that has come a long way, but still has a ways to go in terms of the level of maturity that is required for it to be like really integrated into the processes of these organizations. So that's what we're going to talk about today, is thinking through what are some of the biggest gaps between what machine learning can offer right now in terms of that infrastructure and what the needs and expectations of those enterprise organizations are.
Got it. That sounds good.
Cool. So if we were to break apart machine learning into a few big general areas, I'm kind of stealing from the paper here, but I personally agree with it. It would say that there's the notion of model training and optimization, which generally there are pretty good tools around that, like scikit-learn, Carrot, if you use R, like there's good libraries and good infrastructural support for training machine learning models. The second thing that happens once you have a machine learning model trained is you need to score it. And this is a place where I think the field has come a long way more recently, so that there's production level support for scoring machine learning models so that you can say, put it behind an API endpoint and you can hit it with some other service. There's SLAs and uptime guarantees around that endpoint so that, it doesn't just go down unexpectedly. That's something that would be a problem when you're in production in an enterprise, for example. So scoring there's probably still some ways to go, but scoring is not the biggest gap anymore. The big gap is around, how would I call this exactly? Maybe governance. So governance includes things like, how do we secure our models? How do we manage and version our models? How do we control who has access or permission to those models, if they need to be secured and isolated and controlled? How do we roll over to new versions of the models in a way that doesn't disrupt their service to all the people who are using them? So this is the kind of stuff that's involved in, say, managing data or managing software at an enterprise scale, but there's not great tools for machine learning here.
Yeah, I was gonna bring it exactly there, because this is an area that, so I'm a software developer. It's an area that's pretty mature in software development. You've got version control with different repos that's hosted in a certain way. You've got testing architectures and everything that can run on server environments. You could just check in on them with the dashboard. You've got rolling out versions. You can roll back if something's wrong with the new version. There's access control. So basically all of the things that you just listed are solved problems in the software space. And I'm not as familiar exactly with the data and database space, but to at least a similar degree are solved problems there too.
Yeah. So in the database space, it's totally the same. So slightly different set of questions that you might have or problems that you want to solve, but it's like, who can you part of it is discovery. Can you find what data is available? Like, are there good tools for serving up all the data that's available to you? Can you figure out which ones you have access to, and do you actually have access to them and not to the ones you're not supposed to have? A lot of database systems support these notions of data versioning and data provenance, which is how are all the different data fields related to each other, because usually there's these kind of complex relationships that need to be captured and propagated through so that when things change, if there were, say, an audit, you would be able to trace it back to root causes of those changes. So these are things that are also have some pretty mature solutions in the database space.
Interesting. So when I think of machine learning, I kind of think of two pieces. There's the model itself, and then there's the data that goes into the model. So the data that goes into the model is either coming in through a service or is perhaps already stored in a database. So are we talking about governance specifically around the models themselves?
We're talking about all of it. We're talking about the way that this paper breaks it down. It's called Cloudy with a High Chance of Database Management Systems, DBMS, a 10-year prediction for enterprise-grade ML. So this is still talking about, where things are going to be maybe in 10 years. They're not there yet, but these folks at Microsoft primarily are thinking a lot about where it might be going. So one of the things they point out is that what is a model? Well, a good way to think about it is a model is a software artifact that's derived from data. So both the kind of model, the software part of the model, like what was the scikit-learn version that I used to train this, and what were the hyperparameters that I put into my training command, and what other pre-processing steps did I have before that? You have to keep all of that in order. And then there's also the data that you actually use to train the model, and you have to keep all of that data under control in order to be able to say that you really are managing the entire machine learning model in that vision,
Right, that makes sense.
And one thing that I thought was an interesting point here is that in enterprises, a lot of the enterprise companies that want to introduce machine learning into their processes, into their systems, they're not companies that necessarily have tons and tons of institutional support for their data scientists. They might not have gigantic data science teams. If they do, those data scientists might not be able to get their needs prioritized by, say, the IT people or the software people. But instead, a lot of times the skills that are valued in those the data science teams in enterprises is like understanding the domain in which the company is operating. Like if you're the data scientist at, I don't know, Walmart, really understanding large scale retail is probably where, what you've been hired for, or what you're getting a lot of kind of encouragement from your system, from your colleagues to understand a lot about retail. That means that you're probably not spending tons and tons of your time thinking about stuff like, how am I going to build a data versioning system? So it's in this weird spot where the data scientists who are in these large enterprise organizations, in some ways they have the highest need with respect to like really high grade data and machine learning model management systems, but they're comparatively poorly resourced to actually build it or create it themselves because, they're not Google, they're not Netflix. These are not companies that are data science or software or technology first. Instead, the data science, the software, the technology, it serves this other purpose.
That's really interesting. I hadn't ever thought of it that way in terms of because they're enterprise and because they probably didn't start off with a strong data science prioritization, and maybe that'll be different for enterprise of 50 years from now. But because they didn't start off with that, and because they now have to integrate this new, technology, ML, and all of these new people, data scientists, I hadn't considered that those people would be under-resourced in perhaps a lot of ways.
Yeah, so there's a lot of need that is being identified here for like thinking through, okay, what are the long-term needs? What's the long-term infrastructure or problems that machine learning needs to be thinking about right now in order for machine learning to reach its full potential in enterprise organizations in the next 10 years? Again, that's kind of the premise of the paper. And so that takes us to the forecast is, as I said from the title of the paper, cloudy with a high chance of database management systems. This kind of brings us to the second paper, which I think has some overlap in the authors list, which is thinking through, okay, if we want to have machine learning in the enterprise, and enterprises right now use databases to manage their data, and those databases seem to, generally address most of the major needs of enterprises. They have very widespread adoption and all this kind of stuff. Then is there a way that we can take the machine learning model into the database so that some of this high level, management, access control, version control, all of the sort of stuff that you get for free on your data when you have it in a database, in like a professionally managed database management system, that all of that would also potentially apply to the model if the model's inside the database?
That is such a strange idea to me. Because intuitively, I think of, like, you've kind of got two things. You've got data, which is not executed, it's used. And then there's code, which is executed. And I guess something like a trained ML model is kind of in between, actually, because like you said, it's an artifact of the data. I don't think it would have ever occurred to me to solve this problem by just shoving the ML model into the database.
Well, and it's not totally trivial to figure out how you would do that, right? Like,
yeah,
you query the database using SQL, structured query language, and there's kind of a certain set of conventions, and there's, at least for me, a certain way that my brain works when I'm thinking about writing a SQL query. And then, like you said, when I'm writing a machine learning model, my brain is kind of working in a different way, and I'm using a different programming language. There's different conventions that I'm following. There's different libraries that I'm using. So these are two systems that have not been designed to fit together particularly well. And so a lot of times what data scientists are doing right now is they'll have these strings of scripts, or they'll have modules in a workflow that are bouncing back and forth between the two systems and trying to take advantage of some functionality in one system and then pipe it over to another system for a different set of functionality, and back and forth, and coming up with these kind of long, complicated pipelines. And so, the idea of trying to put all of this together, like what does that look like if we wanted to push this all just into a database? So it makes sense that it doesn't make sense, because it's not something that's particularly been solved before. But this brings us to the second paper. It's called Extending Relational Query Processing with Machine Learning Inference. And so this is a more technical paper, but it's actually going through a system that they are prototyping. It sounds like right now they have like a working prototype at Microsoft. It's called Raven. And it's a system that allows you to package together SQL and machine learning model, like a scikit-learn, like regressor or a neural net or whatever, all together in one piece that can be executed within a database runtime.
Oh, interesting. So not just stored in the database, but also executed alongside the database queries.
Yeah. So when you're working in the database queries, what you're doing is you're mostly manipulating what's called relational algebra. That's like the term for kind of the rules for writing SQL queries. And when you're working with a machine learning model, a lot of times what you're working with is linear algebra, which is matrices and vectors and multiplying them by each other. And so these are kind of two different systems that think about, one of them is based more around like set theory and one branch of mathematics, if you want to think about it that way, like this, the SQL database stuff. And then machine learning and linear algebra, different systems. So what they needed to think through was, what's a way that you can bring both of these two types of algebra together in a system that can deal with both of them. And what they do is, well, it's actually it's got some complexity to it, and we probably won't go into all the complexity here. But they've built this system that's rests around this notion of what they call an intermediate representation, or IR. So the intermediate representation is this representation of imagine you have a pipeline. So it's got some SQL stuff at the beginning where you're manipulating data. Maybe there's some, if let's say you're implementing it using scikit-learn, like you might have to do like a one-hot encoding a feature, or you might have other kinds of feature transformations. Those steps in the pipeline then terminate in a, let's say, a decision tree or a linear regressor or linear classifier or something. Mm-hmm. So the intermediate representation is a way of representing all of the steps in that pipeline in one coherent place. So you've got relational algebra coming in, SQL stuff. You've got linear algebra coming in. There might be some, like the one-hot encoding, you might need some actual special implementation stuff to handle some of that if it can't be handled nicely in either relational or linear algebra. So the intermediate representation, long story short, is where a lot of the kind of complexity of balancing and optimizing and getting all of these pieces working together, that's where that happens. And then once you get it into that intermediate representation and optimized, then it can be packaged up and executed in, it sounds like there's kind of a special version of a SQL Server database that they've adapted so that it can support like a larger set of rules, like a larger set of queries or something, if you like. And so then you pass the intermediate representation like into that special SQL server that's got this larger functionality. And then you've got your machine learning pipeline and it's running in your database.
That's pretty crazy. So you have increased complexity around that intermediate representation and the way that the database actually executes all of this code, and it's got things that it's trying to optimize for and balancing those things together. But the things that you gain are basically getting all of the stuff that you want for your ML model for free from what you've already figured out for your database. And if you're an enterprise company, you've already figured that stuff out for your database, and if all your ML stuff plugs into that same system in a fairly intuitive way, then you don't need to train up new people in terms of the way that you operationalize, configure. You don't have the added complexity of having two systems of permissions, one for your models, one for your data. That coalescing together is, it seems really valuable, especially for enterprise companies.
Yeah, I think that's the goal. So these papers that I was reading were not layering in then all of that meta database management stuff. Instead, it's just proving that from a technical perspective, like, we can make these two systems play nice inside the same runtime together. I think figuring out how to have a good user experience while you layer on all of that extra stuff is probably something that they're still working on. So this is not like you can go out and buy it off the shelf right now, from what I understand. This is longer term stuff. But yeah, I think that's the long term vision, as we were saying in the first part of the show, that on, say, the 10-year time scale, these are things that probably need to happen. Like, you need to figure out how to bring machine learning into this database system, think about what that might look like. And they've demonstrated by building Raven here and proving that it works reasonably well, that that's technically feasible. And so, there's non-trivial amounts of work still to be figured out how to, like, productionalize this, but the big technical proof of concept is documented in this paper.
Yeah. I'm really glad we did this episode. I didn't know any of this going into the episode. These moments where, so I'll just speak for myself. I'll say that when I have these moments where I hear about two things that I think of as fundamentally different or fundamentally separate, or, oil and water, and I hear about some methodology or strategy for combining them or making them the same in some way, or putting one inside the other, it's kind of a cool feeling to feel that, like, ew, yuck, that's gross. But then to actually explore it and to see the ways in which it actually makes more sense than it intuitively feels like it would. And from my own experience as a front-end web developer, I had that moment with CSS and JavaScript. So CSS is the language that tells the website how to display things, like your sidebar is on the left or the right, your sidebar is this big, your background color is this, or whatever. JavaScript is the what do you do on the page? What do you do when you submit this form? What do you do, like, if a user clicks the button, do you move this thing in from the left or whatever? And there's just I always thought of them as completely independent from each other, pretty much. And then this strategy came out that put CSS basically inside of JavaScript. And it was completely unintuitive. And actually, there are a lot of people who still maintain that it's a terrible idea and are very upset about it. But I kind of love those moments, those paradigm shifts, because it challenges all of our ideas of what is the quote-unquote right way to do something, and maybe opens our minds up a little bit and exercises our imagination. Linear Digressions is a Creative Commons endeavor, which means you can share or use it any way you like. Just tell them we said hi. To find out more about this or any other episode of Linear Digressions, go to lineardigressions.com. And if you like this podcast, go ahead and leave us a review on iTunes so other people get to listen to this content too. You can always get in touch with either of us. Our emails are ben@lineardigressions.com and katie@lineardigressions.com in case you have comments or suggestions for future shows. You can tweet us at lindigressions. Thank you for joining us, and we'll see you next time.